So today we're going to talk a little bit about the midterm. I just want to give you a few clues to what's going to be on it. It's a 20-question midterm, and you have 120 minutes to finish it. That's 2 hours. It covers all of lessons 1 through 6. Every single lesson is represented on the midterm, but because of the distribution of the material, some lessons are a little more heavily represented than others, right? Back in 7.1, we first started talking about sets, and we did a lot of different things with sets in 7.1 and 7.2. So lesson 1 is fairly heavily represented on the midterm, because we did a lot of different things. Other lessons we did maybe basically one concept, right? Whereas in lesson 1 we did a whole bunch of different things, right? Remember, a set is a bunch of objects, so we'll say A might be 1, 2, 3, 4, 5, and maybe B might be 2, 3, 5, 7. Just as an example, and we did some things, some operations with those sets, some just basic operations. So a bar, got to get the universal set down there. Universal set can be 1, 2, 3, 4, 5, 6, 7, 8 maybe. Just for the heck of it, we'll make that the universal set. A bar is everything that's not in A, so that would be 6, 7, 8. B union A would be the two sets lumped together into one set. 1, 2, 3, 4, 5, and 7. Or B intersect A bar, let's say, is going to be the intersection of the B set, right, the overlap of the B set and the complement of A. So the overlap is 6, 7, and 8, and 2, 3, 4, 5, 7, and that would just be 7. Don't forget your order of operations. Remember that A bar union B bar is not equal to A union B with a bar over the top. This one you complement the A, you complement the B, and then you union. This one you union A and B, and then you complement. I think I'll erase these and do those two up above. So A bar union B bar. Well, let me do A union B first. A union B is equal to 1, 2, 3, 4, 5, 7, and A union B bar over the top of the whole thing is everything that's not that. So that would be 6, 8. I believe that's right. On the other hand, A bar, we already said was 6, 7, 8. And B bar is 1, 4, 6, 8. That looks right. And A bar union B bar is the union of these two. 1, 4, 6, 7, 8. Clearly not the same as that. And we have De Morgan's law that tells you that those are different things. That this one's equivalent to A bar intersect B bar, and this one's equivalent to A intersect B bar. Okay, so we had our early operations. We also had some relations between sets. Remember that two sets are equal if they have exactly the same elements, and also remember that A is a subset of B if all of the elements in A are also elements in B. Right? So if A is 1, 2, 3, and B is 1, 2, 3, 4, then A is a subset of B. On the other hand, if C is 1, 3, 4, 7, then A is not a subset of C, right? Because it doesn't have 2 in it. All of the elements in A would have to be elements in C, and that's not true. So A is not a subset of C. So we had the relations, the equals relation and the containment relation, or the subset relation. We had translations. Suppose, I don't know, E, we use some different letters here. E equals the set of all the set of all donuts with sprinkles. Right? And F is the set of all donuts with frosting. And G is the set of all donuts that are filled. Don't know where I came up with donuts, but that seems like it should work, right? So E bar intersect G. Okay, these are all the donuts that don't have sprinkles. The understood universal set in this case is all donuts. Donuts without sprinkles that are filled, right? Filled. They're both don't have sprinkles and they don't, but they are filled. On the other hand, F union G bar. This is the set of all donuts that either have frosting or are not filled, or both, right? So the set of all donuts that have frosting or are not, right? So or being the connective and being the connective for the intersection, or being the connective for the union, or are not filled, or both. I don't usually bother with the or both because that is understood. So I'm going to write that down, but then I'm going to cross it out because in the translation I would normally not be including that. Right? And you have to be able to go the other, coming back to this for a second. Donuts with sprinkles that are not filled, there's not, I managed to avoid the and word in there because when you have the intersection, a lot of times you can describe things by describing two, just using two descriptors rather than saying these donuts that have sprinkled and are not filled. You can just say it all in one line without the and connective. It's not as careful a translation, but it means the same thing. So there's that. And going the other way, of course, you have to be able to take things that are written in English and retranslate them into symbols. Okay. We also did Venn diagrams in this 7.1, this first lesson, which also includes counting. Remember your Venn diagrams. So A intersect B bar are all the things that are in A but are not in B. This is one that you really should be able to write down. That's A, this is B, all the things that are in A but not in B are right there. Or A intersect C bar union B, our three-set Venn diagram. Let's see. All the stuff that's in A, I think I used 2 on the top usually, so we'll do this. This is A, this is B, and this is C. All the stuff that's in A and not in C, so this is all this stuff, put together with all the stuff that's in B, right? So that's all that stuff. Notice that you add back in a little part of C when you do that, because this should include everything that's in B, so that's got a shade in all of B. This should include everything that's in A and not in C, so that's this little 3/4 moon right here, and together it makes all that there. Whoops, not that. Sorry, got a little carried away there. Okay. So you want to practice your Venn diagrams, certainly. Anything else from 7.1? No. Still in lesson 2, still in lesson 1 is 7.2, and this is counting, right? And you had your formulas, N of A union B equal N of A plus N of B minus N of A intersect B, right? That's basically the same formula we'd use for probability, but with probability that had P's on it. We also use Venn diagrams. Right? Venn diagrams are a good way to count things. Maybe we'll do one quick one. I don't want to spend too much time doing a lot of examples, because this is something that you can do and go back, and you should be doing, going back through the quizzes, going back through the homework lessons, and trying these problems and looking at them and making sure you can recognize them and making sure you can do them. Watching me do it is really not a lot of help. I'm just trying to jog your memory. It's all about you doing it. But let's suppose we had 150 people surveyed, and 37 read the paper, and 53 listen to radio news, and 24 read the paper, but do not listen to radio news. Okay? So our Venn diagram here, we can have our paper people, And we can have our radio news people, 37 read the paper, but we can't put that in because that's 2 areas. 24 read the paper, but do not listen to the radio, so this is 24. That makes that 13 for a total of 37. Radio, 13 are here, 53 in total. This is 40 here, right? This gives us a total of 53 and 24, 77. And that gives us 73 out here that don't read the paper or listen to radio news, right? And so you can answer all sorts of questions about that. You know, how many people listen to radio news but don't read the paper? 40. How many people do neither? 73. How many people either listen to radio news or read the paper? And that's 77. So there's a lot of information there, and you want to practice those. There'll be some counting questions on the test, probably even a 3-set counting question. So you're going to need to work on filling in those 3-set Venn diagrams, and there's a bunch of those in the book also. Okay. So a fair chunk of the final exam, you notice all the different things I did. I probably did 6 or 8 different things there. The fair chunk of the final exam, the midterm exam is gonna come from lesson 1, because we did a lot of different things in lesson 1, right? We did a couple of different things in lesson 2 also. We had the multiplication principle. Right, so this is 7.3, the multiplication principle, where we worked on counting, right? You know, suppose you're taking a 10 question multiple choice quiz with 4 answers for each question. So how many ways can you answer that quiz? Right? Well, we have 4 ways to answer the first one, 4 ways to answer the second one, 4 ways to answer the third one, ... times 4. That's a mag. I think we did this one in one of our other videos, but I'll just do it here. 4 to the 10th power is 1048576. All right, 1,048,576. Just as an example. Or throw out one more maybe. How many codes can be made from the letters A, B, C, D, E? How many 4-letter codes can be made from A, B, C, D, E? Okay, so if repetition is allowed, that's one question. And when repetition is allowed, you have 5 choices of the first one, 5 choices for the second one, 5 choices of the third one, and 5 choices for the fourth one. That's 625, right? 625 different codes if you're allowing repetition, right? If repetition is not allowed, five times 4 times 3 times 2. 20, 60, 120. Really cuts down on your number of options when you don't allow repetition. Just as an example, right? So these are all applications of the multiplication principle. And I think I'll leave that for 7.3. Once again, I'm just trying to jog your memory and throw out some examples, but there's 100 different examples I could give you on the midterm that uses the multiplication principle, so you need to go back and review the quiz and the homework questions and things like that. We also did 7.4 in lesson 2. This was sample spaces in the beginning of probability, right? A sample space is the list of all combinations of outcomes. It is the list of all possible outcomes, right? And you have to think combinations. Frankly, it's the multiplication principle all over again. So, for example, if I have you flip a coin and roll a die, how many outcomes, or draw the sample space, right? Well, it's the combinations. H1, H2, H3, H4, H5, and H6, and T1, and T2, and T3, and T4, and T5, and T6. Those are all the combinations of a roll of a die and the flip of a coin. It's 12 different combinations, right? And what's the probability that something's even, let's say? The probability that you got an even roll, well, the denominator is the total, 12 different things can happen, and the numerator is 6. This one's even, 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 and this one's even. Does it make sense to talk about even heads or tails, right? So the even has to be referring to the number. Or what's the probability that something's a t and odd, let's say, right? T and odd. The denominator is 12 again, right? And of those 12, how many are t and odd? 3 of them. Right? And when you have that sample space in front of you, then you can just count. And certainly, you know, every section is represented on the midterm, so there'll be something to do with sample spaces. And so you want to jog your memory on that. I think we also, in 7.2, we did probabilities using tables. Last thing from 7.2, lesson 2, probabilities using tables. Right? Suppose we have 0, 1, 2, 3, and the probability of each one is 0.23, 0.52, 0.18, and whatever's left. That's 70.07. Just as an example, and what's the probability that we get 2 or more? 2 or more is these two together, 0.18 plus 0.07 or 0.25. These can be very easy, very straightforward, but people get them confused because of the structure. They don't read what's being asked. They often do this as an expected value question because they think, oh, I have a table with numbers and probabilities, it must be expected value. You have to pay attention to what's being asked, right? And know how to tell the difference between a question that just asks for the probability and a question that asks for the expected value. So you can't just automatically do things the same way when it looks the same way. You have to pay attention to what's being asked. So there's that. And some people just don't. You need to practice tables because they should be basically free points on the midterm, and they're not always free points on the midterm. So work on those also. Lesson 3, we had a pretty dense section in 7.5 with probabilities. And basic probabilities, some of these involved the multiplication principles, some of these involved tables, some of these involved formulas. We had the formulas. The probability of E union F equal the probability of E plus the probability of F minus the probability of E intersect F, right? We also had the probability of E bar equals 1 minus the probability of E. So we had these different things that we were doing, and that use formulas, and sometimes you want those formulas. Particularly, we ran into problems that were very hard to do if you didn't use the complement. So you really need to spend some time reviewing those homework questions, reviewing those quiz questions, because there's some things that are pretty involved in this section. I think those are probably, despite the Bayes theorem being on this, I think these were the questions that were trickiest coming from this section, right? So not a lot of questions from lesson 3, but some of the harder questions are from lesson 3. We also use Venn diagrams for probability. So if you had a Venn diagram that looks like this, right, and you might have had to create this yourself, 0.23, 0.13, 0.25, and let's see what's that. It's 48, 51, 61, 0.39. Right? So what's the probability that something's in B and not in A, right? Well, that's your 0.25. Or what's the probability that something's in A or in B? Well, A or B is your 0.61. So being able to draw the Venn diagram, being able to interpret the Venn diagram, all that stuff is important, right? So there's that. And the last thing we did in 7.5, which once again should be easy points, but often is not because people don't bother reviewing it, right, is odds. So remember that the probability of E is the good divided by the total, and the odds for E are the good divided by the bad, or the good to the bad. And that, I'm just going to say that and encourage you that if you have no idea what I'm talking about, to go back and look at the video on odds, because this is by far the way that people have the most success. Not by memorizing a lot of formulas, but by understanding what odds are and understanding what probability is, right? So review that, because once again, that's something that, just like the table, should be free points on the quiz. All you have to do is count, right? But they're often not, and people just kind of fall apart on the odds because they have don't remember that relationship at all. So you want to definitely work on that, right? So through 7.3, I think we're talking, let's see, we still have to do, we still have to do the expected value, conditional probability, and base theorem. Now the conditional probability will come in some of those other probability questions. So through lesson 3, we're talking close to 3/4 of the test. 14, possibly 15 questions on the whole test from those first 3, because that's where we did the biggest variety of things. On the other hand, lesson 4, expected value, right? E is equal to the value times the probability plus the value times the probability plus ... and you just keep going till you run out of values. And mostly I'm going to refer you back to my lecture on expected value from lesson 4, because, and the homework questions and the quiz questions, because there's a huge variety to the questions. There's all sorts of different things that we use to do expected value, from oil wells to raffles to rolling die and flipping coins. Lots of different things that we did use expected value for. And so you really need to go back and you need to review those questions on expected value. And I think I'm going to leave it at that, actually. There will be a couple expected value questions. I don't think there's any lesson that we don't have at least 2 questions on the midterm. So go back and look at your expected value stuff, because that's going to be important. There will be a couple of questions. It's only one concept, so it'll only be 2 questions, but there will be 2 questions, and they'll be different from each other. I don't want to just test one type of problem. Lesson 5, on the other hand, is the conditional probability, right, and independence. So in 8.1 is the conditional probability, right? Probability of A given B is the probability that A happens. Given that B has happened. Okay. I think probably my favorite question with conditional probability is the contingency table. So I haven't done one of those yet. Let's do that, right? So if we do a contingency table, I won't do my favorite one this time. We'll do rural, suburban, urban, and income level, high income and low income. I think I'll just do high and low, just to make this a fairly quick example. So you go out and you interview a whole bunch of people. Let's just see what our total is, and you found 4 rural families with high income and 12 suburban families with high income, and let's see, I guess we'll go with 14 urban families with high income, and the low income bracket 26 rural families with low income, and 18 suburban, and say 26 again urban, for a total of 30 rural families and 30 suburban families and 40 urban families, in a total of, what's that, 30 high income, and, oh, I came up with 100, how nice. And so this should be 70 then, if I did that right. 52 and 18 is 70, for a total of 100. Okay? So I guess you didn't, that part was not important to you, but this part is. What's the probability that somebody's high income and or intersection rural? Well, the probability somebody's high income and rural is 4 out of 100. 4 people out of the total. There is no conditional probability here. It doesn't say given. On the other hand, what's the probability somebody's high income given that they're rural? So we restrict ourselves to just the rurals because that's the given. You restrict yourself to the given, so that's 30. You guys can see that, right? No, you cannot. Yep. Guess I'll have to do that up here. What's the probability somebody's high income given that they're rural? So the denominator is 30, right? And the numerator in that case is 4. Or what's the probability somebody's rural given their high income? The given sets your denominator, right? So that's this row right here. Oh, that one's also 4 out of 30. Shoot. Oh well, 4 out of 30. So you could get that one right whether you did it one way or the other. That won't happen on the test. You can't do it wrong and get it right. The numbers will be different. Or what's the probability that somebody's suburban given that they're low income? Okay, given that somebody's low income, that means we're only looking at the low income people. So the denominator is 70, and of those people, how many are suburban? 18. Right? So conditional probabilities using the contingency table. Certainly we can do conditional probability using sample spaces, using our rules, lots of different things. But this is a lot of times you can just count. And if you can count, like in a sample space or a table situation, then you should always count. Some people use the formulas to calculate these things, but the formulas lead to a lot of errors, so you want to be really careful. If you have a table situation, sample space situation, you should be counting to find probabilities, not using formulas that calculate probabilities and then calculate more probabilities from the probabilities. For one thing, you're introducing a lot of error when you round, and for another thing, you're introducing another opportunity to make an error, to make a mistake. So you want to try to be as close to the source as possible. So there's that conditional probability. In 8.2, we talked about independence. And one of the things you were doing for the homework in 8.2 is you were asked to prove that some things, that two sets are independent, that two events were independent. I will not be asking you to prove that two things are independent. I don't think that's a critical thing for you to be able to do. When you take statistics, you can learn how to do that. On the other hand, you might be using independence if A and B are independent, then probability of A intersect B is equal to the probability of A times the probability of B. When two events are independent, we have this special formula that generates the probability of the intersection. Other than that, you have to use conditional probabilities to do it. But when they're independent, then the probability one happens does not affect the other. So keep that in mind. We probably will use that on the midterm, right? You'll have to use that somewhere on the midterm. So you want to keep that in mind for the midterm, but realize you will not have to prove that they're independent. So a bunch of the homework questions were about that. So finally, lesson 6 is also on the midterm, and that's our Bayes theorem stuff. Don't want to go on too long. I've got 40 minutes here on this video, so I think I'm just going to remind you of Bayes theorem. It really is just a conditional probability, and remind you that I recommend the tree diagram approach. I think that's the easiest way to do those problems. So work on the tree diagram approach. Make sure you're recognizing the Bayes theorem questions where you have this sequence of events. In some ways that's hard. On the formula sheet, which I should be sending around this week, I believe I have the Bayes theorem formulas. In spite of the fact I don't recommend you use them, they'll be there for you if you need them. But it's in the, if you want to look at it ahead of time and figure that out, it's in the file section in Canvas, the midterm formula sheet. So, so there's that. Remember that you are allowed writing utensils, calculator, and scratch paper for the exam, and also that you're being asked to submit your handwork within 2 hours of finishing that exam. Get that scanned and put it in the midterm handwork Dropbox, so that I can do that regrade. I regrade all your exams. For your quizzes, you can look at them and you can check them over, but I'm not going to give your exams back to you. You're not going to have access to them again. So, so I have to be the person that looks at those exams, gives partial credit, et cetera, et cetera. So your first grade when you're done with the exam is probably not going to be your final exam. It's very unusual that there's not a little partial credit in there. The exception to that rule is if you've gotten high 90s or 100, then those grades weren't necessarily going to change. But there's always other stuff that I have to look at. So I will look your exams over, and you will submit your handwork so I can look at that and assign partial credit if necessary. So that's your midterm exam. Hopefully you've scheduled your exam and you're all ready to go, and good luck.